Welcome to Spring LIB.
Our question wants us to look at figure 26-25A, which gives the magnitude of the electric field that have been set up by a battery along a resistive rod of a given length of 9.00 millimeters. And it says here to see figure 26-25B. The vertical scale is set by E sub s equals 4.0 times 10 to the third volts per meter, and the rod consists of 3 sections of the same material but different radii. And this is important here. So since the material is the same, the resistivity is the same, only the radii here are going to be different. And the radius of section 3 is 2.0 millimeters. From this information, it wants us to find the radius of section 1 and the radius of section 2. Well, as mentioned, the material is the same, the resistivity is the same, which implies by equation 26-11 that the electric field in the various rods are directly proportional to their current densities. Thus, the ratio of those current densities, which we're right here as J1 to J2 to J3 for the 3 different rods, is 2.5 to 4 to 1.5. And you can get this from figure 26-25. But the currents in the rods must be the same since they're in series here. Therefore, since the currents in the rods must be the same, J1 times A1 has to equal J3 times A3, where A is the area of the different rods, and J2 times A2 has to be equal to J3 times A3. And the area here is equal to pi r squared. So therefore, we can use these ratios to get the radiuses of the first rod and the second rod. So for part A, here, R1, since the pi's are going to cancel on both sides of the equation, they're just a constant, is going to be equal to the square root of 1.5 to 2.5, which I got from the ratios of the current densities, multiplied by R3, which we were given. And this comes out to be 1.55. Units here are millimeters. We can box that in as our solution to part A. Now, doing the exact same thing for part B, we find that R2 is equal to the square root of 1.5 to 4 times R3. And this is equal to 1.22. Units here are millimeters. We can box that in as our solution to part B.